And we gave you a couple of equations there. One of them is very similar to ones we've looked at before. Let me see. So, at the very end of the day yesterday, I had written up on the board. Just put it in a big pot right there. All right. So last thing we left with. It's already in your notes, so you don't have to rewrite this. I just want to refer to it. Okay, that's the last thing we talked about, right? All right, with this, like I said earlier, that is how we can find out the temperature at which a process will become spontaneous, which is a nice thing to know. And then lastly, I have this little chart there, and I want to look at the effect of temperature on spontaneity, okay? So here's an equation that we're going to refer to quite a bit here. And there's a handy dandy little chart. Obviously you don't have to reproduce this because it's already in your little packet. But this is a nice summary of things. My suggestion would be, well, you can do whatever you want. This is what's already in your notes. This information has already been provided, right? And now it's just a matter of evaluating the influence of temperature on this by looking at these scenarios and this relationship. Okay? So, remember, if enthalpy is negative, which means what? Is that an exothermic or endothermic process? Everyone together now. Delta H is negative, is an, okay, we just took a quiz on that. That is an exothermic process, okay? If delta H is negative, that's an exothermic process, so heat is evolved. If delta S is positive, what does that tell us? What does that tell us about the particles and or energy? Is it more ordered or less ordered? More dispersed or less dispersed? Okay, it's more dispersed. Remember, entropy is the dispersal of energy and or matter. Oh, that's going to be really wet. Okay. So anyway, with that being said, what is my value of negative T going to be, or what is the sign going to be of negative T delta S if this is true? It's going to be, well, delta H isn't included. Delta S is positive. So if delta S is positive, then the entire quantity is going to be negative. Okay. Now, if this quantity is negative and the delta H is negative, what influence is that going to have on our delta G? What is the only thing it can be? Negative. I'll do these in blue or red or something. Orange. Let's go with orange today. Make it a pacer day. We'll go with orange. Alex, makes sense? Yeah. Excellent. Moving on. I just picked on somebody I haven't picked on for a while. Now, the next one, we've got a delta H of positive, meaning endothermic or exothermic. This is endothermic, so energy is being absorbed by the system. The delta H is, or the delta S, sorry about that, is negative. What does that mean? What's that? Less dispersed, interestingly enough. Okay? less dispersed, more ordered, in other words, okay? And what is my sign of negative T delta S going to be then? Positive. And if negative T delta S is positive and delta H is positive, what is my value of delta G going to be? Well, if both this component are positive and this component are positive, then the delta G is going to have to be positive. Okay? So, what this is essentially saying is, if I want to look at the spontaneity, this would be spontaneous at all temperatures. Anytime you have a negative delta G, it is going to be spontaneous. So no matter how high the temperature is, okay? Think about this. The larger the value of temperature, what's going to happen to this value? It's going to become more and more negative the higher the temperature is. Does that make sense? The more and more negative it is, the more and more negative the delta G is going to become, the more spontaneous, the greater the extent of the process. Over here, though, since our delta S is negative, the higher the temperature, the higher the numerical value, the more positive the numerical value, which means the more positive the delta G. So that means this is going to be non-spontaneous at all temperatures, regardless of the temperature. Okay, but now we get into this scenario. Exothermic process, negative delta H, negative delta S. Okay, well, what's my negative T delta S going to be? Positive. What is my value of delta G going to be? Well, that's going to make it interesting. This term is going to be negative. This term is going to be positive. Would you agree? So really, what is this dependent on? The what? The magnitude of this quantity, which is governed by the temperature. You see where I'm going with this? The higher the temperature, the more positive the value of this term, therefore the more positive this term. Does that make any sense? Okay, so in that scenario, it is going to be, I want to see if I word this right. Okay, so this is temperature dependent, and meaning it is spontaneous at low temperatures. Remember, the higher the temperature, the higher the magnitude of the negative T delta S, which is going to result in a more positive delta G. We can get to the point where that makes the delta G positive, therefore no spontaneous. So a process such as this is going to be spontaneous at low temperatures. So I can put either positive or negative here. Depends on the temperature. Does that make sense? And then over here, a positive delta H, a positive delta S, okay, which is going to make our negative T delta S term negative. Right, Lauren? Okay, if I separate this out, okay, and the delta S is positive, because of that negative sign there, the whole term, negative T delta S, is going to have to be negative. Okay? You with me? So now, once again, this has to be negative to be spontaneous. The delta H is already positive. This is negative, but is it negative enough to make the delta G negative, right? So once again, it's going to be temperature dependent, right? So once again, we're going to have either positive or negative, and the spontaneity is going to be temperature dependent once again, except now it's going to be spontaneous at high temperatures. So the higher the temperature, the more likelihood that it's going to be a spontaneous process. Those are the types of questions that you guys will be asked to consider quite a bit on the AP exam. Okay? They'll just give you some values. They don't have to give you values, but they can give you values and you'll just go, oh, well, it's going to be spontaneous or not spontaneous. In fact, I've seen a chart very similar to this before on multiple choice questions where you had to figure out which one's going to be spontaneous, which one isn't. Okay. That is essentially what we're going to cover out of chapter 18 for now. We will not revisit chapter 18. Well, we're going to do some problems, have a quiz on it, probably have a test over everything in chapter 6 and 18. But where I'm going with this is we've covered the material that we're going to cover right now. Later in the year, towards the end of the year, once we've gotten equilibrium done, we'll come back and revisit the small pieces for both chapters 18 and 19 that are related to equilibrium. Which is good because that's a good time to review that material anyway.